The science of vaccination and immunisation, it relies entirely on the body's own ability to adapt and develop immunological memory. The development of immunological memory relies on the immune system having been triggered in the past by an antigen. So, what happens when the body receives a vaccination or naturally comes into contact with an antigen? We have the non-specific or innate immunity. This is the first line of defense. It's indiscriminatory in its ways of killing the invading pathogen. We also have the adaptive immunity, which is the second line of defense. This incorporates both the cell-mediated immunity by the T cells, as well as the antibody-mediated immunity by the B cells. So on day one, a pathogen enters the body and infects the cell. The B lymphocytes travel through the lymph and blood to the infected area, where it binds to the antigen-presenting cell and forms a complex. The binding activates the T helper cell to release its interleukins. This promotes the differentiation and proliferation of both the B and T cells into active antigen-releasing plasma cells, cytotoxic T cells, as well as B and T memory cells. The plasma cell's endoplasmic reticulum then synthesizes antibody proteins called immunoglobulins, which are specific for the antigen. These bond to the invading antigen and mark them for destruction. IgM is the major primary immunoglobulin involved in the primary response. It forms a pentamer, which connects 5 different antibodies through disulfide bonds. During the initial exposure, there's a latent period of about 5 to 7 days. After the exposure, the antibodies continue to circulate and will be catabolized, leaving the immune system primed for the second exposure. During the secondary response, when the antigen presents itself for the second time, the antigen will be dealt with in a quicker and more effective way as long as it's 28 days from the initial infection. The swift reaction of the memory cells results in a larger amount of antibody production with a smaller latent period. Production of the IgG is increased significantly, making it the prime immunoglobulin at work. So once exposed to the antigen, the raised IgG levels may be evident for decades, providing immunological memory. We have a few different ways of acquiring immunity. First, we have the naturally acquired immunity, which is when we come into contact with a microbe or through the transfer of antibodies between the mother and its offspring. We also have the artificially acquired immunity, which is through vaccination, as well as being injected with antibodies. Finally, we have homeoprophylaxis, which is a form of homeopathic immunization. In conclusion, vaccination and immunization work because it promotes immunological memory. So if you don't get exposed to a particular antigen through vaccination, your body won't develop an immunological memory to that antigen, and you may therefore be susceptible to infection if your body lacks the specific immunological defenses.